Tutorial sheet 4, question 1, relating to time division multiplexing and pulse position modulation. So what do we have? Well, first of all, we have to recall what the process of pulse position modulation is and time division multiplexing. So if you consider time division multiplexing first of all, so what we have is we're going to have our signals that we're trying to multiplex together. First of all, we're told a channel sampling frequency, which is equal to 8 kilohertz. In other words, that's how often each channel is sampled. So that's going to give a time that's required between each sample of 1/8,000. And so let's say that sampling time is there. So what we're going to have is a situation where we're going to have a pulse and the position of that pulse, which has a pulse width of 2 microseconds, and that pulse can move in a certain distance, and we're told that pulse shift is plus or minus 3 microseconds. So this pulse can move around 3 microseconds, and the position of that pulse determines the amplitude of the signal that we're trying to sample. And so this pulse is allowed to move around, and what's going to happen is there will be another channel. Let's draw it at a slightly different amplitude just to denote it's a different channel. So that would be channel 1, and this would be channel 2, and again that one can move around, and so on and so forth. So we would have a third channel which can move around as well. So obviously these pulses need to be able to move around so that we can appropriately assign an amplitude to the signal. But they can't overlap, so channel 1 can't overlap into channel 2. And so the whole question is about how many channels can you fit in to this time period before you have to resample channel 1 again and start the whole process over again, because we have to keep resampling channel 1 due to the Nyquist theorem, which is given here, so we have to keep sampling this at 8 kilohertz. So how do we go about solving that? Well, we know the pulse width is 2 microseconds, and we know that the pulse shift is plus or minus 3 microseconds. So the total position that this pulse can move over is obviously 6 microseconds. And it has a width of 2 microseconds, so we have that onto it. And there's also a minimum separation between one channel and the next. So if I was to redraw that and just zoom in, so if I say that that's my channel width, and if my pulse from channel 1, if this is channel 1 and this is channel 2, what we can't have is that obviously those pulses crossing over, and we're told that the minimum separation is 2 microseconds between each pulse. So we've got to add that on as well. So our total channel time that we're allowed for each channel is 6 plus 2 plus 2, which is equal to 10 microseconds. So each channel needs a maximum of 10 microseconds for the pulse to be able to move around it. So what we need to work out is how many 10 microseconds can we fit into 1/8,000. And if you work that out, what you get is 12.5 potential channels that you can fit into 1/8,000 microseconds. And of course you can't have half a channel, so the final answer is that you can the number of channels is equal to 12.